You should have a sheet that says stoichiometry problems. That's what we're talking about today, stoichiometry. When we deal with stoichiometry, what we're talking about is the math involved with an equation to help us figure out if I have this much reactant, how much product can I make? Or if I made this much product, how much reactant did I have to start with? So this is the math that is involved in the balanced equation to determine amounts of reactant and product. The important thing you have to do very first off is make sure you balance your equation because it's all based on your balanced equation. So you always refer back to that balanced equation for each step of your problem. You have different kinds of problems for stoichiometry. And the sheet that I gave you divides them up into 3 different parts. You have mole-mole conversions, which is I have moles of something, I want moles of something else. Okay, so I have moles of something that I know, I'm looking for moles of something I don't know. The second one on here says mole mass. You can also do mass mole. They're just the opposite of each other. So I have mole mass or mass mole. And then the third or fourth type, depending on how you divide up mole mass and mass mole, is mass mass. I know I have this many grams of one thing. How many grams of something else can I make? We laid the groundwork for this yesterday with mole calculations. You know, if I have this many moles of aluminum, I can find how many grams that is. All we're doing now is taking moles of one substance and finding moles of another substance based on our balanced equation. So I'm going to walk you through the examples, and then we're going to do some practice. Can I put up a clean page? All right, look at your first one under mole-mole calculations. Sulfuric acid is formed when sulfur dioxide reacts with oxygen and water. Write the balanced chemical equation for the reaction. So first step, write your equation. What do I have to start with?
Sulfuric acid. Sulfur dioxide reacts with oxygen and water.
Okay, so I have sulfur dioxide reacting with oxygen and water. What am I making? What's formed? Sulfuric acid. We haven't talked about acid naming yet. Sulfuric acid is H2SO4. Is that balanced?
Yes. No.
Let's check it. We have sulfur, oxygen, and hydrogen, right? I have 1 sulfur, 5 oxygen, 2 hydrogen on the left, 1 sulfur, 4 oxygen, and 2 hydrogen on the right. Am I correct? Did I count it right? Okay, so we've got 5 and 4. If we have an odd, what do we always try to do?
Make it even.
We try to make it even. So I'm going to start with a 2 right here in front of H2O, which gives me 4 H's and 2, 4, 6 oxygens. Now what do I need to do? When I doubled my H's, what happened to my O's? Threw my O's off even more, right? And now I have 4 H's on the left and 2 H's on the right, so how can I remedy that?
A 2 on the right.
A 2 on the right. So that's 4 H's, 8 O's, and 2 S's. Now what? Two in front of SO2, which is 2 S's, and 4, 6, 8 O's. Are we good? Okay, so we've got our balanced equation. This one comes up again later, so just make sure you have it written down because you'll use it in another problem. The question they ask, if 12.5 moles of SO2 reacts, how many moles of H2SO4 can be produced, and how many moles of O2 are needed? So what do you have a number for?
Your moles.
You have moles. So when you write out a stoichiometry problem, sometimes it helps if you write, I'm given 12.5 moles of sulfur dioxide. That's a 2. I'm given 12.5 moles of sulfur dioxide. My arrow tells me I need to know, what are they asking me?
How many moles of H2SO4?
All right, how many moles of H2SO4? They're asking me another one too. I'm going to go ahead and put that one on here. How many moles? This pen is acting crazy. How many moles of O2? So how many problems am I going to have to set up?
2.
2 problems because they're asking me 2 questions. Always start with what you're given. 12.5 moles of SO2. When I set up my equation, I want what on the bottom because I want to cancel.
A mole. 1 mole.
Well, this one's not going to just be 1 because this is not the same substance. We're doing different substances. So what would I put on the bottom to be able to cancel out? What unit?
SO2.
Moles of SO2, yes. So I want moles of SO2 on the bottom because I want to be able to cancel it out. I want what I'm looking for, moles of H2SO4 on the top. So what I have is on the bottom, what I'm looking for is on the top. Then I go to my balanced equation and I say, okay, I have a 2 in front of SO2 and I have a 2 in front of H2SO4. So this is called the mole ratio. And it comes from your balanced equation. Always, always. You go back to your balanced equation and you read the coefficients of the numbers or of the substances that are in your mole ratio. You with me so far? So now I can cancel moles of SO2. I can also cancel my 2's, right? Because 2 over 2 is just 1. So how many moles of H2SO4 do I have?
12.5.
12.5 moles of H2SO4. It worked out nice that time. It won't work out that way every time. It won't always come out to be the same. Question so far? Okay, the second thing it asked me for was how many moles of O2. So I take what I know, 12.5 moles of SO2. I set up my mole ratio. I need SO2 on the bottom because it's what I know. On the top, I need what I'm looking for, moles of O2. I go back to my balanced equation. There's a 2 in front of SO2 and nothing in front of O2, which means it's 1. So I can mark out moles of SO2, multiply across 12.5 times 1 is 12.5. Bring across your 2. How many moles of O2 do I have?
6.25.
6.25. Question on the first mole example. Not sure where a number came from, not sure a step that I took. Another example. I'm going to put up a clean page. Number 2. A reaction between methane and sulfur produces carbon disulfide, a liquid often used in the production of cellophane. It also produces H2S, but it didn't say that. So I take my equation. They gave me my substances. I have methane, CH4. I'm combining that with sulfur to make carbon disulfide and hydrogen sulfide. Is it balanced?
No.
No. So I'm going to make my list C, H, and S. I have 1 carbon, 4 hydrogens, 8 sulfurs on the left. 1 carbon, 2 hydrogen, 3 sulfur on the right. So my hydrogens don't match and my sulfurs don't match. I want to start with hydrogen, so I'm going to put a 4 in front of H2S, which gives me 8 hydrogens and 6 sulfurs. What else can I do? I don't know why I put a 4. Why did I not put a 2?
I was about to say,
I had a senior moment there. It's 4 and 4. Now what can I do? I think I was trying to fix the sulfurs. What else can I do to it? Put a 2 in front of CS2, which gives me 2 and 4, 6. So now I have to correct my carbons, right? Put a 2 over here, 2, 8. We're still not quite there, are we? I need to make hydrogen be 8, so I'm going to change this to a 4. I had it right the first time, didn't I? And 4 is 8. Does that look good?
Yes.
Everything checks out, all right. All right, so A was balance the equation. We took care of that. B, calculate the moles CS2 produced when 1.5 moles S8 is used. So given 1.5 moles of S8, what do we want to know?
the amount of CS2, the moles of CS2.
All right, the moles of CS2. So write what you know, 1.5 moles of S8. I need my mole ratio with S8 on the bottom and CS2 on the top. How do I get that mole ratio? Where do I find the numbers that go in this fraction?
The numbers in front of the thing.
Okay, your coefficients from your balanced equation. So in front of CS2, I have a 2. And in front of S8, it's implied to be 1. Moles of S8 cancel. So how many moles of CS2 do I have?
3.
3. Question about where we got that? Part C, how many moles of H2S are produced? What do you have a number for?
1.5 moles of S8.
Okay, 1.5 moles of S8. What do you need to know?
H2S.
Moles of H2S. So I put H2S on the top, S8 on the bottom. And I go back to my balanced equation, right? And H2S has a 4 in front of it. S8 has nothing, so it's a 1. How much H2S can I make?
6.
I can make 6 moles. Question about mole calculations. Feel pretty good about this so far. Okay, your second type is mole mass. Can I put up a clean page? Problem 3. Titanium is a transition metal used in many alloys because it is extremely strong and lightweight. Titanium tetrachloride is extracted from titanium oxide using chlorine and coke, which is carbon. Is your equation balanced? They give you an equation this time. How do I know if my equation's balanced?
Check it.
Just count it, right?
Yeah.
So on the left, I have 1 titanium. On the right, I have 1 titanium. On the left, I have 2 O's. On the right, I have 2 oxygens. Left, 1 carbon. Right, 1 carbon. Left, 4 chlorine. Right, 4 chlorine. So are we balanced? Okay. If you begin with 1.25 moles of TiO2, what mass of Cl2 gas is needed? So we are given 1.25 moles of titanium 4 oxide. What are they asking us for?
So mass of 20.
Okay, so it's grams of chlorine because your masses are in grams. Start with what you know. 1.25 moles TiO2. For this kind of problem, your first step is to do a mole ratio. So on the bottom, what you're getting rid of, moles TiO2. They're asking us for chlorine, so I put moles of chlorine on the top. But they're not asking for moles, they're asking for grams, right? So remember your conversion from yesterday? 1 mole of something is the periodic table mass of that substance. So now we got some blanks to fill in. From our balanced equation, we can find the number in front of moles of Cl2 should be 2, and the number in front of moles of TiO2 should be 1. That part came from my balanced equation. Then for the grams of Cl2, where do I look? I look at the periodic table. So chlorine is 35.45, and there's 2 of them because it's Cl2. It should be 70.9. It's 35.45, and it's Cl2, so there's 2 of them. So it becomes 70.9. Now I cancel what I can. So moles of chlorine cancel. Moles of TiO2 cancel. Multiply across 1.25 times 2 times 70.9. And the bottom is all ones. Agreed? So I don't have to worry about the bottom. .25 times 2 times 70.9.
177.25.
177.25. Very good. .25 grams of chlorine. Question about where a number came from. I'm not sure where or what I did for something. Number 4 is an example of this too. It's also a mole mass. For number 4, sodium chloride is decomposed into the elements sodium and chlorine by means of electrical energy. How many grams of chlorine gas can be obtained from 2.5 moles NaCl? So if it's decomposition, I'm starting with sodium chloride. When it breaks, what is it going to become? Sodium and chlorine. And we have talked about this, but it's been a while. There are 7 gases that do not exist as single elements. Chlorine is one of them. So it's Cl2. The ones you need to remember are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They do not exist as just Cl, just I. They're always Cl2, I2, O2. Okay? So how do I balance this? All right, 2 in front of NaCl and 2 in front of Na. Very good. So I have my balanced equation. I am given 2.5 moles of sodium chloride. What do they want to know?
Grams of chlorine.
Grams of chlorine. So I'm going to set it up. Take what I know. 2.5 moles of sodium chloride. I go from sodium chloride moles to chlorine moles. So I put sodium chloride on the bottom because I want to cancel it. Looking for chlorine. And then I need a mass. So I need 1 mole of chlorine in so many grams. I'm going to go back to my balanced equation for my mole ratio. In front of Cl2, I don't have a number, so it's 1. In front of NaCl, I have a 2. And then I need a periodic table mass for chlorine. And didn't we find that in the last equation?
35.
And there were 2 of them, right? So 70.9, yes. So now I cancel moles of chlorine and moles of sodium chloride. I'm going to work through. So 2.5 times 1 times 70.9. The top of my fraction is 177.25. And then 2 times 1 on the bottom is 2. So when I work that out, how much? 88.6. 88.6 grams of chlorine.
Should the bottom number not equal 5?
2 times 1?
don't you take the 2.5 and multiply by 1? Or multiply by 2?
It's like saying this is over 1.
Okay.
That's why. If it helps, do it that way. If you forget. Does that make more sense?
Yeah.
Other questions on mole mass? Okay, your third type is mass. So number 5. One in a series of reactions that inflate airbags in automobiles is the decomposition of sodium azide. Determine the mass of nitrogen produced if 100 grams of sodium azide is decomposed. So they gave us an equation. 2 sodium azide yields 2 sodium and 3 nitrogen. Is it balanced? Yes. So they give us 100 grams of sodium azide. What do they want to know? The mass of nitrogen produced. So what you're going to find is this adds one step. The setup is the same. We just add one more box, okay, or one more fraction. We know that we have 100 grams of sodium azide. Our problem is we can't work with grams. We have to get it to moles because our balanced equation is based on moles. So we did this conversion the other day, or yesterday. 1 mole of sodium azide, we need grams to cancel that out. Where do I find that? Where do I find the mass of 1 mole? Periodic table. So I have sodium, 1 of those, and 3 nitrogens. Sodium is 23, nitrogen is 14. So my mass of sodium azide is 65 grams per mole. Okay, now I've got it in moles. I have to do a mole ratio because they're not asking me about sodium azide. I already know that. They're asking me about nitrogen. So I put sodium azide on the bottom so that I can cancel it. And nitrogen on the top because that's what I'm looking for. And I look at my balanced equation. There's a 3 in front of nitrogen and a 2 in front of sodium azide. But they're asking me about mass. They're asking me grams. So I do that last step that we did before. 1 mole of anything is the mass from the periodic table. And down here I saw that nitrogen is 14. There's 2 of them because it's N2. So it's 28. Question about where a number came from. I'm going to cancel moles of nitrogen, moles of sodium azide, and grams of sodium azide. Then I'm going to multiply across. 100 times 1 times 3 times 28 is on the top, which gave me 8,400. And on the bottom, I have 65 times 2, which is 130. And then I just divide. What do you get? 64.6 grams of nitrogen. Question. This is as hard as stoichiometry gets. That's the good news, right? Clean page. Number 6 is your last example. In the formation of acid rain, sulfur dioxide reacts with oxygen and water in the air to form sulfuric acid. Write the balanced chemical equation for the reaction. I told you a while ago to save that equation because you're going to see it again, right? So if we go back, 2SO2 plus O2 plus H2O is 2H2SO4. So it's 2122. 2SO2 plus O2 plus 2H2O yields 2H2SO4. So we got that part done. If 1.5 grams of sulfur dioxide react with excess oxygen and water, how many grams of H2SO4 are produced? They're kind of introducing the idea of limiting an excess reactants. If it is excess, what does that mean?
It's extra.
It's extra. So it's not important to my equation because I have more than I need. The limiting is what's important, and we'll talk about that Monday or Tuesday. But limiting means it got all used up and I can't continue my reaction. So again, not important to this equation, but just kind of have in your head, limiting, I run out of it. What are we given in this one? What do we have a number for?
1.5 grams of SO2.
1.5 grams of SO2, sulfur dioxide. And what are they asking us?
How many grams of H2SO4 produced?
All right, how many grams of H2SO4 or sulfuric acid? So start with what you have a number for, 1.5 grams sulfur dioxide. I can't use grams, so what do I have to get it to?
Mole.
I have to get it to moles. So 1 mole of sulfur dioxide, we need grams, and where do I get those?
Yeah.
Periodic table, so I've got S and O, 1 S, 2 O's. S is 32, O is 16, multiply across, 32 and 32, my mass is 64. I'm not being asked about SO2 though, I'm being asked about H2SO4, so what do I have to use? What do you call the step when you look back at the balanced equation?
Oh, the ratio.
I need the ratio. So I need to go from moles of SO2 to moles of H2SO4. So I look at my balanced equation, and H2SO4 has a 2 in front of it. SO2 has a 2 in front of it. And finally, they're asking me about grams of H2SO4. And I know that 1 mole of anything, I can get the mass from where?
Yeah, okay.
The periodic table. So I have 2 H's, 1 S, 4 O's. H has a mass of 1, S has a mass of 32, and O has a mass of 16. So I have 2 plus 32 plus 64. I got 98 grams per mole. So I fill that into my equation. Everybody good on understanding where those numbers are coming from? I can cancel moles of sulfuric acid, moles of sulfur dioxide, and grams of sulfur dioxide. Then I work across 1.5 times 2 times 98 is 294. And then the bottom, 64 times 2 is 128. And then we divide. How much did you get? 2.3 grams of sulfuric acid. Question?
Is that realistic?
Yes, this is what you're actually going to use next week when you carbonate your Kool-Aid. And we usually make cookies, but I got to figure out a way to do that. Because what we do is the no-bake cookies. So I got to figure it out. I'm going to stop the recording.
Is that what people